Alrighty, good morning everybody, or afternoon, or possibly even evening, depending on where you're joining us from today. Welcome to the June edition of the Showcase Webinar Series. The title for today's episode is Jack and Slide, Everything You Need to Know. My name is Jonah Hodgson. I'm from ITI. We have a short agenda there on the right. I'm going to do a very brief introduction to the guests we have on the line joining us today. We're going to go through kind of the practical applications and kind of the physics behind the Hydra-Slide for one, and then horizontal load moving in general. We have Robins and Morton. We're very pumped for them to join us today. We've got a case study going through the actual use and the horizontal load moving of a condenser unit. And then if we have time at the end of today's presentation, we're going to do live Q&A over the air. So we have a bunch of guests with us today: Pat Clark from Lifting Gear Hire, Don Mankey and Janine Smith from Hydra-Slide, and then Frank Green and Sonny Calderon from Robins and Morton. It's going to be pretty exciting today. We're always pushing the limit on the Showcase Webinar Series, so you're going to see, it's a lot of people you're going to be hearing from, but you're going to be able to see who's speaking at all times. We've got the webcams set up. It's optional. You guys can toggle that on and off or not, but it's pretty cool. You can actually put a face to a voice and still see the computer screen while we're going. Very briefly, for new folks on the line, at ITI we can boil everything we do down to one sentence that you see there. We exist to serve and learn every day. You can see some of the folks we've been lucky enough to work with, to serve and really learn from our customers there, and we have the globe up there because our trainers can go anywhere. We've trained on every continent except for Antarctica, training centers at 6 locations in North America, 2 in Brazil as well. So that is ITI in a nutshell. We have Lifting Gear Hire. They're actually our Showcase Webinar partner for 2016. They came to us about the idea. Everything worked out just perfectly culturally, and our mission alignment for both companies is just, we're all about the same thing. We want to help the industry, so the partnership just makes sense. And to talk a little bit more about Lifting Gear Hire, I'm going to turn it over to Pat here just for a moment.
Thanks, Jonah. Yeah, as you said before, we've started developing a partnership with fine folks such as ITI in an effort to provide quality information to our audience. We are absolutely the leader in the industry when it comes to safe, certified, customized rental rigging, hoisting, winching, and material handling equipment. But we also felt strongly by partnering up with folks like ITI and other ones that this will help keep people even a greater safety degree than before. So as Jonah said, we've got a lot of distribution centers throughout the United States, soon to be Canada. We have 21 locations, but again, everything is certified and meets or exceeds the ANSI, OSHA, and ASME standards that are out there now. So in a nutshell, it's about renting safety, and we follow that mantra every day. It starts in-house. But again, I'm going to flip this back to Jonah. And Jonah, please go ahead.
Alrighty. You guys will be hearing plenty more from Pat later. Don't worry about that. Back to ITI for a second, kind of our modalities, if you will, for delivering training. We can go to client locations, as I mentioned. We have training centers in Washington State, in Houston, in Memphis, in Chicago, in Cleveland, and a satellite facility in Anchorage at this time, as well as a full-time facility in Edmonton, Alberta, Canada. And then specifically the training courses, you can see the breakdown there. Cranes, rigging, lift planning and management, and certification. We have a certification partner through NCCCO to deal with any type of load handling certification. Our company, I mentioned training and e-learning a bit. I just want everybody to know the ITI bookstore is a great resource center, undoubtedly the largest in the industry. Anything you need, reference cards, ASME standards, really anything. Any type of tool that's going to help you guys out in the field, you'll be able to find at the ITI bookstore. We also have a consulting or field services division. And then we have on-site workshops and then webinars like the one we're on today. So real quick, again, I want to thank Hydra-Slide and Robins and Morton and Lifting Gear Hire for joining us. We're going to have Don Mankey and Janine Smith on the line from Hydra-Slide. What they do is they make skidding systems. So there's two models, a low-profile track and a heavy track. And as you can see on the screen, there's different capacities for each, depending on the job and the load. I invite everybody, probably not right now, I stick around for the webinar, but once we're done, check out Hydra-Slide.com for more information. And then Robins and Morton. Again, we have Frank and Sunny with us. Thank you guys for joining us. The Power and Industrial Division was actually founded in 2011, and that's Frank and Sunny represent that division. But they have sectors. They're very busy in healthcare, commercial, government, power, and industrial as of 2011. So check them out online as well, robinsandmorton.com. And finally, if you guys have questions today, they're bound to come up. Please submit them in the question pane so I can get them to our panel at the end of the session. If there's something you're not comfortable asking or you don't want me to ask over the air, that's okay too. You can say that in the question that you submit, or you can just email me privately. It's Jonah, Jonah, @iti.com. So I think with that is more than enough for me. What I'm going to do now is turn things over to Pat. All righty.
Okay, thanks, Jonah. Again, I want to introduce Don Mankey and Janine Smith, President, Vice President of Hydra-Slide. We started developing a relationship just a couple of years ago, and it's been proven to be very, very successful from a support role. Again, a lot of our business models line up, and we were looking for a partner, and I think they were looking for a partner as well. On the buy side, they make a high-quality product that you'll see here shortly, and any inquiries from a standpoint of purchase, I would encourage you to go right through them. As far as a partnership from a rental standpoint, that would be us. Lifting Gear Hire is their United States and Canadian rental partner. So without further ado, I'd like to welcome them and get started. They've got a lot of good quality information, so get strapped in. Here we go.
Thanks very much, everybody, for having us. We're very excited to be here. And I'd like to start, obviously there's a lot of different ways of moving heavy loads, not just jack and slide. Some of the really typical applications for moving heavy loads, you can use cranes, you can use gantries, you can use forklifts, things like that to lift a load and move it and place it somewhere else. You can also use roller systems for putting a load on and either pushing or pulling it around to move it in place. And then obviously the reason we're here today is to discuss more about the jack and slide method. So we don't claim that jack and slide is the only way of doing something, and on one job site there's probably going to be tons of different kinds of equipment being used simultaneously. There's going to be boom trucks, forklifts, possibly cranes, slide systems. So it's really important that we educate our customers and potential customers on making informed choices to, make money, save time, do things as safely as possible. With cranes, they're super powerful, very versatile pieces of equipment. They can move loads extremely high in the air and move them into different places. When you're using cranes or gantries or other lifting methods, the dynamic forces do come into play. So, your wind, your ground support, there's a lot of planning that has to go into those jobs. The same can be said for using a roller system or something a little lower friction. Your dynamic forces of motion are going to come into play. So, what we say with rollers is, the great thing about them is that they move something really fast. But the bad thing about them too, or something you have to be aware of, is that they move something really fast and you have to have a plan in place to stop that. So today we're going to look a little bit more specifically at the jack and slide. So I'd like to introduce Don, or sorry, no, I don't want to introduce Don yet. I'm not done. So jack and slide, what it is, it's moving a load horizontally on tracks. It's a guided system. So your load sits on shoes on a track, and it's moved horizontally using push cylinders. Usually your load is jacked up first to be placed onto the slide system, and then it's pushed laterally. It can also be referred to as jack and roll. It's a little bit of a misnomer because we're not using rollers. We're using a controlled friction surface and skidding, always pushing against the slide system. So we have the controlled movement. Okay. And when we talk about big, heavy loads, you know, something that weighs a couple 100 pounds could be a challenge to move in certain situations. The slides you see on the screen now are examples of super heavy loads. And so there's skid systems available to move something, you know, the bottom picture there is a 19,000 ton offshore platform being skidded. And the slide on the right is a close-up of a load-compensated skid shoe for moving heavy loads. Some of the benefits of using a skid system over some other methods. Skid system doesn't care what it's moving. You know, it can be used to move transformers, vessels, components of oil rigs, refinery components, machines. Everything moves exactly the same way. They take up very little space, very small footprint. You'll see a little bit closer detail the layout of the tracks and the components of the skid system. Very low height. The Hydra-Slide systems, the maximum profile on our systems is an 8-inch profile on the heaviest tracks. It can go down to a 1-inch profile as well. Typically, there's no external forces required when you're using a skid system. I talked a little bit about rollers. You know, if you're rolling something on a low friction surface, you have to be aware that it's not necessarily lateral movement, and you're not going to necessarily go where you intend to go, depending on, you know, your ground support and other factors. So there have to be winch lines, some holdbacks, something in place to stop that movement if you want to. With a skid system, it's a simple setup. I mentioned cranes. Mobilizing a crane is a job in itself. It takes a lot of time and money to mobilize it. In some situations, it's your only option. In other situations where a skid system can be used, your setup is very short and simple. And our equipment lasts a very, very long time. The first systems that were built by Dawn are still being used in the field, and that's going on 30 years ago. So a little hydraulic component maintenance and some graphite on the tracks, but there's not a lot of things to fail and to need maintenance on a slide system. And they're extremely versatile. I mentioned before, you know, a slide system can move pretty much anything of any size. And now I'm going to turn it over to Don. He's going to discuss a little bit about some of the basic principles physically that you look at when you're using a slide system.
So I just want to go back a little bit. We got a little ahead of ourselves there. No matter which method you choose to use when you're moving a load horizontally, one of the main things you have to look out for is be aware of the physics involved. We're dealing with very heavy weights, and often the physics of it can have a big effect. So in the mid-1600s, Sir Isaac Newton, which I'm sure everybody is aware of, was one of the first people to be aware and to study the force of gravity. He got an understanding of how pieces move, not yet. And some of the physics that sit behind that. And if I asked, you know, most people if they could recite what Newton's 3 laws of motion are, most people probably can't. But if you look at what they are, you'll recognize them right off, and you'll probably say it's much more of a common sense thing. So his laws of motion, his first law is an object will remain at rest or move at constant velocity unless acted upon by an external force. Pretty basic. The second law is acceleration and force are vectors. Now what a vector means, it only means that it's something that has quantity and direction. So if you're talking about force, it's a force in a certain direction with a certain amount, a certain quantity. For the third law, it's every action, there is an equal and opposite reaction. This comes in with a lot of moving, because if you push against a move, technically it's pushing back on you. So often it's that back force push that you really have to deal with. Along with that, if you extend that a little bit further, we can talk about inertia. And inertia is a tendency to do nothing or to remain unchanged. And that is right back to Newton's first law. And then we get led into momentum. And that's a quantity of motion of a moving body, and it's measured as a product of its weight times its velocity. It really means that if you've got something with some weight that's moving, it's got what we call momentum. And I think everybody understands what momentum means. The really important part of it all is the energy that's involved. And if we talk about kinetic energy, that's the energy that something possesses by virtue of it being in motion. And this is where it's calculated by its weight times the square of its velocity. So if you've got something moving at, say, 1 mile an hour, if you double that to 2 miles an hour, it's got 4 times the energy. If you double that again to 4 miles per hour, it's got 16 times the energy. So this is where, when we're dealing with heavy weights and horizontal moving, we really want to keep the speed to a very minimum to keep the energy levels down. And also, when we're talking about energy, there's 2 different kinds. There's potential energy that's really due to its height. This is where it comes in with cranes. If you're lifting an object to a height, you're putting potential energy in it that can then be translated. If it's released, it falls down and it builds up what we call kinetic energy, and the further it falls, the more energy it's going to have. And again, it's this kinetic energy is what we really have to watch out for. And further, and this is getting a little bit more into what we want to talk about today, is friction. Friction is the force resisting the relative motion of 2 surfaces sliding against each other. And we'll often refer to the coefficient of friction. That's the ratio of the force of friction divided by the weight of the load. And when we talk about skid systems, we're normally working in the range of 10 to 20% coefficient of friction. And what this really means is if you're moving something that, say, weighs 250 tons, you got a coefficient of friction of 20%, the force required to move it is 50 tons. So it's going to take you a force of 50 tons to move that 250-ton load. On the same hand, if you're moving that 250 ton on that friction, it's also acting like a braking force. It's an automatic brake. So if you stop pushing something, this friction is going to be acting like a 50-ton braking force to keep it from moving further. So when we look at skid systems, and we'll look a little bit more at some of the applications later on, but just so we know what the components are. Now, I don't really have a pointer here, so hopefully you can see it. The picture on the bottom left, the long yellow pieces, that's what we refer to as the track. This system has a certain amount of strength built into the track. They're very stiff tracks. And you notice the blue circles there, those are the pin connectors. And again, if you refer to the picture at the top right, that's a little exploded view of what the connectors are on our system. They're very simple pin and lug connections. They give a lot of flexibility, but they're extremely strong. So a little bit further, the load is sitting on, again, back down to the lower left photograph, the load is sitting on the blue, that's what we call the skid shoes. Your load sits on there, and that's what moves along the track. And we've got the graphite slide surface that's between the top of the track and the bottom of the skid shoe. That's where your friction is coming from. And that's, as we call it, a controlled friction surface. It's something that is pretty much a known quantity and doesn't change much. Will change a little bit as it's wearing down. Humidity will affect a little bit, but essentially you're in a controlled friction arrangement there. And the orange pieces in the center, those are the push cylinders. That's what actually pushes the skid shoe along. So they're not actually pushing on your load, they're pushing on the skid shoe, so your load is sitting on a platform, and that platform is then being moved along the skid track. The picture on the right lower part is, for every system we put out, we provide what we call safety stop blocks. You do have a controlled friction, you do have the automatic braking, but this is just an extra piece of added safety. These are mechanical connections that would prevent any type of runaway or being pushed any further than you want. And normally those would be set in the track, keeping them a few feet ahead of the move as you're going. So just to keep it all safe and secure.
So Don, just to go back to the coefficient of friction, you have a 250-ton load that if using a crane, that's a pretty substantially sized crane, right? A lot of ground bearing pressure,
yes,
etc. So you could also equate that to maybe somebody who's lifting weights, right? Is it easier to do an overhead press or is it easier to push something, right? I think a lot of people can equate to that, right?
Yeah, it's probably easier to push them in, and again, here when we're talking, I think we'll get into it a little bit further too, but because of here in the track has a ratchet, the bottom of the cylinders actually hook into the track and push against the skid shoe. So all of the forces that are being used and being pushed in there are kept within the system. So when you're talking about a crane, the crane is lifting the load, but it in turn is imparting that force back into the ground, riggers and boom, the force is going through. And again, with the roller system, if you're pulling with cables, you may have smaller friction, but the pulling force, again, if we go back to Newton's third law, reaction has an equal and opposite reaction. What you're pulling against is also experiencing that force.
Right.
So if, I don't mean to go on too long, but if you're pulling against building columns, you could be affecting the strength of the building columns. You may not be able to pull straight. You're going to be maybe pulling your load off center. So with the slide system like this, your forces are always directly in line and all contained within the system. So
at a minimum, you're adding more factors by using all those alternate methods like winches and tiebacks. So thank you.
Now my clicker doesn't work.
Go ahead.
There we go. So when we get into this, we also want to talk a little bit about guided and unguided systems. The picture on the left, and I will again get into that a little bit more. That's moving a large vessel on a roller system. This was something back in my history. The rollers, even though you can point them sort of generally the way you want them to go, there's no real guarantee that your load is going to go in that exact direction. If you have to be pulling off on an angle, again, it may pull you off center a little bit. And also these require winch lines, both for the pulling side and the holdback side. The picture on the right is one of our slide systems, one of our customers pulling a heat exchanger out of a live refinery. You can see he's pulling them out on the track. That's a very precise movement. He doesn't really have to worry too much about the clearances. He knows exactly where the vessel is going to go as he's pulling it out. Now, we talked a little bit about the internal portion. This is just another close-up view of the hydraulic cylinder in there. You can see in the bottom, you can see the ratchet track. The cylinder is pushing against the track, and on the other end, it's pushing against the shoe, which has friction between the shoe and the track. So that cylinder is a 50 to 55 ton push capacity, but that entire force is being kept within that track system itself. So nothing outside of it is experiencing any forces at all. So we want to talk about a lot of the physics that we talked about. What ones of those apply to the skidding system? When we talk about friction, yes, it definitely applies. We're very slow, controlled movement. Again, say we normally operate in the range of 10 to 20%. It's a very high coefficient of friction, but it acts as a brake to prevent unwanted movement. So even though it takes a bit more to push it, we have that push capacity in the track system. But the main thing is that the friction will act as a brake to prevent unguided movement. Guided or unguided, skid systems that we saw are definitely guided. They will direct your load exactly where you want it to go. And when we jump back to the potential and kinetic energy, since here the loads we're moving are generally moving at a very, very low height, very slow, so you don't have any really any significant potential energy, and due to the slow movement, you have very little momentum and very little kinetic energy build up. So you don't really to take undue precautions against the buildup of energy. And we mentioned about pulling at angles, which often you do if you have external forces. With the skid system, your forces are always directly in line with the track, so you're not risking pulling at angles at all. This is what I mentioned, get back into this a little bit. This is going back into a little bit of my history. This picture was taken around 1980, early 1980s. This is how I was working for a heavy transport and rigging contract at the time, and we moved a lot of large loads, a lot of vessels like this, a lot of transformers. And the way we did it was with pipe rollers, put the rollers under the vessel, pull on one side with winch lines. On the back side, we'd have a holdback. It worked, and we're able to do it relatively safely, but one of my concerns, and here's another transformer coming off a rail car in the same way. One of my concerns with all this was, number one, the amount of equipment and the amount of personnel you needed to do it, but the general safety concerns with it. You're pulling one direction, you've got winch lines around, you've got tripping hazards, you've got dangers with the winch lines, you've got the holdbacks. If your load starts to run away on you a little bit, you have to be in a position to be able to stop it. And once the load starts to run a little bit, it starts building up energy, it could become a big problem. And further to that, in placing the rollers, the guys were always in there placing the rollers with their hands. Mm-hmm. Always kind of a concern to me for the safety. We never had any injuries, but maybe that was more luck than anything. Mm-hmm. So I was lucky to be with a company that gave me a lot of latitude. So instead of doing that, I came up with a way of maybe doing it with hydraulics. It would eliminate the pulling forces, the pullback forces. This picture was taken in 1983. That was the first skid system that they ever built or ever worked with. It was kind of proof of concept. When it was designed with 50-ton 4 cylinders, both sides, designed for about 500-ton capacity. And it actually worked very well. But when we got into it, we started realizing the kind of work we did, we really wanted more strength in the track, be able to span gaps and a few more things. So I went back to the drawing board, and about the following year, we came up with this. Same principle, but a much heavier track arrangement, the pushing cylinders fit inside the track. Same principle to what we saw before, but it gave us some strength. And just what Janine was mentioning before about the longevity, this system that we built in 1984 is still being used today, and actually still being used quite a bit. So I'll pass it back over to Janine a little bit to talk about a few of the advantages.
Thank you. So I'm going to start with this photo here. This is one of our low-profile systems in a transformer station. So you can see that there is very little clearance on the sides as well as overhead. So, looking at moving this transformer, crane would be very challenging to get in, and rollers, again, dynamic forces, a lot more to consider, a lot more variables at play in the environment. So the slide systems are very good in tight places. That slide system there, the LP400, is a 2-inch profile. So you don't need a lot of overhead space. You need to jack maybe, 4 to 6 inches to get the track underneath, lower it down onto the track, and then push. This one here is one of the heavy track systems. Don's already talked a little bit about the precise movement. Where you lay your tracks, that's where your load's going to go. There's no risk of your load going in an uncontrolled direction or ending up not where you want it. And because it does move relatively slowly, and some people say, can't it go faster? And it's if you're moving a 500-ton piece, how fast do you really want it to go? With the synchronous power units that we offer and LGH offers for rental, you go about 60 feet an hour, which is still a good rate, and your mobilization time is a lot reduced from some other types of equipment out there. So with that being said, you're moving not that fast. You can precisely place your load onto a transformer station, onto a rail car, wherever you're moving it, within a 1/4 inch. We have guys out with tape measures measuring exactly where they want that load to be placed. And the surface conditions aren't that much of a consideration with the slide system. You still need to know what your ground pressures are and what kind of surface you're going on. But you can lay mats down, steel mats, wood mats, to spread the PSI out over a long span, and then place your load over it. So that's in northern Alberta, where they typically have very sandy, kind of loose soil. Talk a little bit more about the surface conditions. The photo in this slide shows a vessel or a transformer. What is a transformer? It looks round for a second. Being moved over a surface where you're going from concrete onto gravel and back onto concrete. So again, it's a matter of placing matting down and making sure you're sliding over a relatively level surface. So your elevation changes, your matting requirements, things like that aren't as much of a consideration as some other types of load moving techniques. This slide here is showing a vessel being skidded, and you can see in the photo that the track is spanning gaps of several feet with this load. They've basically got some blocking under the connection point, which the connection points always need to be blocked because, as you saw in the photos before, it's a pin and lug, and there is a little bit of a gap there, so there's no strength in that track at that point. Other than the connection points, the slide systems do come with a stamped engineered load capacity chart that's on the right side of the screen, so you can calculate exactly how many feet you can span between block piles depending on the weight of the load that you're moving. The way it's read, the vertical column is your weight per skid shoe. Typically you're using 4 skid shoes. You could use more if it's a different configuration that you've set up, but we'll go with 4 for this example. And the horizontal axis is the feet that can be spanned between block piles, between blocking. So if you look on the left, that's in 1,000 pounds. If we calculate based on a 200-ton transformer, a 200,000-pound transformer, which is 100 tons, your weight per shoe would be 50,000 pounds. So if you go to 50,000 pounds on the vertical axis and over, you can span a gap of 12 feet between block piles. A lot of times our customers will block a little bit more just because the safety guys and the customers like seeing more blocking, but the track is strong enough to take that load over that span.
So Don, I have a question for you. You and I have talked a lot about cranes. Certainly we support the crane industry heavily. This is not anti-crane. Give me the top 3 quick cliff notes of where a Hydra-Slide jack and slide system is most beneficial versus a crane.
Probably most times in most applications now is moving transformers. When they design the transformer stations now, they tend, because slide systems are available, they'll design the transformer stations with all the overhead obstructions in, with narrow spots, because they know they can get them in. And they've actually made a lot of the spots very difficult to use a crane in, even if there was suitable in other ways. There's a lot of other applications, such as inside plants, where we're working with headrooms, we've got tight clearances. There's actually a lot of uses for it. It's a little bit of using the imagination. Yeah. Sometimes people think, well, if I can't get a crane in, I can't do it. Yeah. If they look at slide systems and other things, they'll find out that they actually can do it, and can do it very easily.
Yeah, to that point, the units that we've had on rent, majority of them have not been used for transformers. It's been really for low headroom applications, maybe going through a tunnel. But that being said, what other vessels besides transformers, because that seems to me the main one. We've got a lot of folks here that are in the mechanical industry, are mechanical contractors. What advice would you give them as far as considerations, or what vessels this would be ideal for?
I think basically anything that's got to move, pretty much you can probably use a slide system. Okay. And that we find actually the market for it, or the uses for it, is so large, it's hard to kind of pinpoint it. It can be, as I said, machines inside plants. It can be vessels inside refineries. Any place where you need to move it horizontally, even considering small elevation changes of maybe 5 to 10 feet, you can still jack it and slide it. If you're looking at an installation where you may be putting 50-ton load on top of an 80-foot high platform, you're not going to use a skid system for that, most likely.
Okay. Thank you.
And this is a photo that was taken in Venezuela, a transformer getting skidded onto its pad. Then one of the really nice things about the slide systems is your operator, the guy there in the front running the little power unit, he's at a very safe distance from the load. No one needs to be close to anything while it's moving. And he can position himself so that he's got a clear view of what's going on. He can see where the cylinders are, the hoses, make sure everybody's operating from a safe distance. And then he can at least, there's a blind spot on the back of that transformer where he can't see, but he could have a signal person just making sure that everything is going according to plan. So very minimal personnel is required, and everybody can be from a safe distance. And I'm going to pass it back on to Don to look at some unconventional applications, just kind of more of what Pat was talking about, that it's not just for one type of load. There's countless ways, and some of our customers approach us with, could we use a skid system for that? Yeah, that's a great idea.
Yeah.
Thanks, Janine. And yeah, this is getting back again a little bit more into my history, but it's to your point, Pat, exactly. The skid system, anything that has to be moved horizontally, you probably can use the skid system to do it. This was a large diameter storage tank. We had to move it on site there and then put it on the barge to take it to another town. One of the obstacles we had was we had to cross a river. So instead of building a bridge across the river or trying to take it out on the road and dealing with bridge authorities there, we put a couple pontoons in the river, laid some skid track across, and simply skid the tank across and picked it up with the transporters on the other side. Here's another case where installing a machine inside a plant. That was our one of our jacking towers. There we had a lot of precise movements to make with the machines as they were going in. We had to move them down the aisle longitudinally, we had to move them laterally, we had to rotate them. So we took our tower that had wheels on, we could move it longitudinally with that. And up on the top, along the top beam, that's where a skid track is. That's what gave us the lateral movement to move the machines sideways, very precise movement. And then we had a swivel hook block underneath that to do the rotation. That worked extremely well. I think we set about a dozen machines like that in a very short period of time. Another case with our towers, this was a refinery vessel that needed to be set up on a pedestal. And in this case, we used the skid track underneath the tower. And if anybody's been, back to our previous slide there, we had wheels on the towers. Question might come up with why didn't you use wheels on this one? The truth was, we only had one set of wheels. We had two towers and one set of wheels. So the putting the skid track under the two towers, lifting the vessel, moving it over onto the elevated pedestal, again worked very well. This was a case of a nuclear steam generator. We had to load it on a barge. This was at the Port of Toronto. There was a dock crane there. There was about 250 ton capacity. This vessel was closer to 400 tons, so we couldn't use the crane to load the barge. Again, here we used our skid track. We skid track and a beam. We moved it from the shore onto the barge and successfully loaded it. So back to your point, there are many things that you can do, many applications. This was another case of moving, putting the generator into a very high location in a power plant. We set up a tower, used strand jacks to lift it to that height, and then pulled in some beams with skid track underneath it, unhooked the strand jacks, and slid the generator into the building from the side without having to take apart the roof, without having to use a crane. So just when we talk a lot about cranes, we've said a little bit, and we certainly don't want to diss cranes by any means at all, because they're one of the most common useful pieces of equipment on any construction site. But because they lift the loads almost cantilevered with a boom section, and the load is suspended, they're subject to a lot of different forces. Some of the other constraints with a crane, you depend on the availability, what size your load is, restrictions to the setup area, overhead clearances, we talked about that a little bit. But again, to say with the laws of physics, they're very susceptible to motions that your load takes. In fact, you can almost consider them inherently unstable because the load is suspended. It's only held there basically because of the weight of its machine. It's on a balance. You've got the load hanging off the end of the hook, which can be balanced by the counterweight, the overall weight of the crane. Should any of those things change, if your weight, load weight increases or your lift radius increases, those will increase your overturning moment with no correction in the righting moment. You can also get into influences from wind, say ground instability a little bit. Your crane sinks down a little bit. That's going to have the effect of moving your boom out, increasing the radius that you're lifting at. And swing. If you swing the load too quickly, boom in or out too quickly, you can set up a pendulum type motion with the load, and that's going to impart back to the kinetic energy. It's you creating kinetic energy. These are things that are all going towards increasing the overturning moment of the crane. And I've got to apologize for the next slide a little bit here. If you do that, if you go a little bit too far, you lift a little bit too heavy, you risk the instability of the crane. So again, my apologies for for a cheesy slide. Costs can sometimes be a deciding issue. If all things being equal, whether you can use a slide system or a crane. If you look at here, this chart, and there's no numbers on it because it may vary depending on what area you're in. But the axis on the left-hand side is your cost. The lower axis is your load weight. So what you'll see with a skid system, the cost of using the skid system doesn't really change that much based on what weight you're using. It's all, it's a little bit labor intensive, small equipment. It takes a certain amount of time to set it up and to use it. So it doesn't mean that much difference to it if it's moving a 50-ton load or a 400-ton load. Whereas a crane, it's almost the opposite. If you've got a 40 or 50-ton load, very easy to get a hydraulic crane, pull in, pick it up, move it. It can be fairly. But with cranes, once you're getting to the higher end, if you're getting into several hundred ton, 3, 4, maybe 500 ton, your crane costs become rather exponential. So at some point there's a crossover, and this is what is showing in there. Lighter loads, often the cost effectiveness may favor a crane. Once you get a little bit heavier loads, the cost effectiveness may favor a skid system. So this is going to change a little bit depending on the availability of cranes, where you are, so many things, but there does usually tend to be a crossover point. Where we were, normally the crossover point was somewhere between 80 and 100 ton. Below, if you could use a crane, sometimes it's more financially feasible to do it with that. Once it was over about 100 ton, then it much more favored the skid system. That's
a good bogey to consider.
So a little bit, what happens if you ignore the laws of physics? This was about a year in Holland. They were setting a bridge section, and you'll see what goes wrong when they basically ignored the laws of physics here. I'm not going to get into at all what I think really went wrong there, although I mean, everybody can form their own opinion. I think there were a lot of things done wrong. And in fact, you might even look at what they were attempting to do. I think they were attempting to do something that is basically impossible to do. There was 2 cranes on 2 separate barges, free-floating barges, trying to swing a heavy load, and we see what happens. So next, this was what happens when you do it right. This is one of our customers in Nigeria. That's a 300-ton buoy being moved off a barge onto shore. And again, the picture seems to be a little bit jerky. This was actually time-lapse photography. From the time it was on the barge till offshore, it took about 2 to 3 hours, but it gave plenty of time for the barge to do ballasting, to keep the level straight. See, the center of gravity is very low, very slow and controlled movement. And this, I think, basically is the proper way to move a heavy load on a barge.
So, Janine, I have a couple questions for you. From a standpoint of slide systems, what have been some of the stumbling blocks or common stumbling blocks in creating the awareness and getting the word out about alternative load handling methods?
It's a good question. I think really our challenge is because there's so many times the skid system can be used. How do you go and market to every single industry and every single application that can be used for? So it's really about education, that they are out there. I think we have a pretty good website. We get a lot of requests through the website, and then picking the right shows and the right partners also to kind of spread the word, which LGH definitely is also. So the challenge is relying a little bit on the creativity of the customers and the different industries out there, and promoting all of the different ways that we see them being used. And just really, when people say like, well, why couldn't you use a forklift or use a crane? It's creating that awareness of the challenges. And like we said, there's more than one right way of doing something, but kind of putting it in people's minds that this is another option in the toolbox. It's something to consider and look at for your specific project and determine if it's the right method for that job.
And on top of that is, when we're talking about a crane, I can't hop in the cab of a crane myself, but on something like this, I've had a chance to work with it and to see how easy it is. Can you speak to that? Someone who has no experience or knowledge in running a Hydra-Slide, is this something you find intimidating? So a guy like me, let's just suppose I hate my neighbor. I want to jack up his house and move it a few blocks away, and I don't have that much knowledge. Could I be able to accomplish that task?
You absolutely could. We obviously recommend reading the operating manual and understanding some of the physics involved, and also 10,000 PSI hydraulics, very high pressure hydraulics, and we kind of get a little bit, I think, blasé about the fact that, it's 200-ton piece, it's a 500, it's 1,000 ton, it's 5,000 tons, and it looks so simple and safe and things are moving slowly, but there's a lot going on. So I don't recommend you jacking and sliding your neighbor's house if you do decide to do that.
Get a professional.
Get a professional. Hire a rigging crew. And we also, we offer basic training. It is, for most experienced riggers and people that are used to doing jobs like this, it's very intuitive to use. It's simple to use. We do offer a little bit of basic training and support if someone needs that. But I think compared to a lot of other options, it's a lot simpler and user-friendly.
Right. Well, thank you very much. As a reminder, I don't know if I said earlier, we are streaming this live on our Facebook page and Twitter, so if you do have some questions, certainly post them, and we'll do our best to answer them either in real time or at the end. So again, thank you, Janine and Don. Read that real quick. Thanks. So with that said, we bring up our next folks from Robins and Morton. We've got Frank Green as well as Sonny Calderon. I've had a chance to get to know these guys a little bit over the last few weeks as we've gotten prepared for this, and we've had a lot of fun. But one thing's for sure, these guys, despite looking at them, I'm going to see Sonny. Sonny looks like he's 16, 17 years old, but these guys are pros. These guys have a lot of knowledge behind them, a lot of experience, and we're just going to get to the tip of the iceberg today and talk about a jack and slide case study. So I want to welcome here. I'm going to let them tell their story and take it from here. So thanks, gents.
So Frank and I are from Robins and Morton Power and Industrial, which was founded in 2011. We're a full-blown EPC firm. So we do power plants, proppant plants, chemical plants, oil refineries, anything. So what we had to do was we had two 305-ton condenser units that were going underneath an SDG tabletop for a 4-on-1 combined cycle. The tabletop is a concrete foundation. It's got columns, and it's got a concrete tabletop, and the condenser sliding underneath, in between the columns and underneath the tabletop.
The 8 foot of concrete on the top of the tabletop, the crane just wasn't an option. We had to come up with something else.
So what we did is we were just going to, normally Frank and I we'll build our own skidding system, our own jack and slide system out of channel iron and other things. We'll use our own jacks. But so we contacted Lifting Gear Hire and started telling them that we needed skates and we needed some channel iron. And, my rep, Dan Gomez, he said, well, what are you trying to do? I explained to him what the situation was, and he told me all about Hydra-Slide and showed me the video and how easy it was to use. And so that's what he sent me, all the dimensions on the shoes and the skid system, and it was going to meet our clearance requirements. We had about 2 inches on each side and 4 to 1 inch up top, so it was really tight and we didn't have a lot of headroom.
So I'm gonna stop you right there. There's a lot of methods out there. What you said in the past, what did you guys use to bring these in?
In the past, what
normally is a channel iron turned upside down with Hillman rollers underneath the condensers or whatever we were typically moving. And like Don was mentioning earlier, things tend to get away on rollers.
Yeah.
And we needed to stay controlled, and we had open trenches that we had to cover and other issues.
Because a lot of these methods go back to building the pyramids, right? These are tried and true methods. They're still used today. So in the past, what were some of those What were some of those negatives about using an uncontrolled system? Don had his experience, but you guys had also real experience with using that with channel rollers.
A lot of times we'll have to use a tugger, and you'll have a tugger up front, and you'll have to contact the vendor for whatever it is that you're trying to roll in, see if your connecting points are okay engineering-wise. Then you have to have the tugger on the back end as a catch. You'll have to, check out what your fleet angles are, and it's a lot of engineering, and it's a lot of time. It's a whole lot more time. And this skid system here, all the hydraulics work simultaneously, so you're not pushing one against another. That's one of the biggest problems we come up when we do one of these without Hydra-Slide.
Can you explain that a little bit more in detail?
You might have, they work simultaneously, so they move at the same time instead of having a cocking motion, which it'll throw your jack and slide completely off 100%.
So in the past, you'd use cylinders, but they weren't necessarily tied together. And if they were, it was a manifold, and that also brought in some extra factors versus using Hydra-Slide and their Hydro Pack, which is designed to synchronously push those. That would, okay.
You're relying on people pushing porta powers.
Yeah.
So we got out of having to do all of that engineering, calculate what kind of tuggers we needed, and Hydra-Slide sent us everything we needed, and Lifting Gear Hire provided us with all the measurements, all the specs that we needed to convince our client, convince ourselves this is the system we need to go by and use.
Yeah, and you met Danny, but had you worked with us in the past?
We've rented some rigging from you guys on a past project.
You have. What in other project would you happen to run across?
On a jack and slide type system?
Just other pieces of equipment.
Oh, we've rented chain falls, spreader beams.
Spreader beams, a lot of spreader beams down there on our project that we have going on in Orlando right now. We have several spreader beams. Did a project in Arkansas not too long ago, using heavy chain blocks and nylon rigging. And we had to get special from y'all.
And from a standpoint of the rigging, I think you guys had a pretty substantial lift. That I know if we had more time, we'd talk more about that. But
we rented most of our rigging from Lifting Gear Hire for our Hersig modules that were both supplied and over 550,000 pounds each. But we also rented all of our rigging from Lifting Gear Hire for the second largest steam turbine in the United States when we went to set it. And all of our lifts went perfectly. They were all critical lifts, and Lifting Gear Hire sent us all the specs we needed, all the certification, everything we needed to a T to back up our insurance and everything we needed in case something happened. So we had everything we needed, and we had it in a timely manner too.
So Danny comes in. He comes in the trailer. I think along with you met Bob Crabb, another personnel of Lifting Gears, and you determined that they have Hydra-Slide. Had you worked with Hydra-Slide's equipment before? I know you've had other jack and slide pieces of equipment. Okay. What if any value did Danny and Bob bring to? I mean, you guys are pros, right? Robins and Morton is an established, reputable company. So how were they able to help you?
It's just like I said, Danny gave us everything we needed. The spec sheets, I wasn't going to tell him what I was doing. I just told him I needed to slide something really heavy into a tight spot, and I knew what I wanted to do. So I started telling him I needed some rollers and some channel iron, and he asked me, what are you trying to do? And I explained to him the situation, and he said, have you checked out this Hydra-Slide? He got on YouTube, he showed me the video of how it works and the clearance issues, and once he gave me the specs on the shoes and the slide, I realized it was going to give us the headroom we needed for such a tight spot.
Cool. So talk about your challenges that you guys had then.
Go ahead. One of the challenges here going in with these condensers, we had an open pit on the back side, 6 foot deep, 10 to 12 foot wide, and we had to span that gap coming through with the condenser. So the tracks being as rated what they are, we're able to span that gap with ease and not have something like Sunday and I are used to doing, that a cobbled up mess, trying to span across it, and a lot of engineering going into it. The engineering was already done.
Yeah.
So we were able to put them in relatively easy. And keeping these controls was the other thing. Using past skid systems like Sonny brought up, not having things synchronized and the skids would get angled on the track itself, and we never ran into any of those issues with this system. It went really smooth.
You really don't have to worry about running away with their stop system on this either. You don't have to have a tugger on the other side pulling the opposite direction.
Right.
They've got stop blocks on the back end of this. So, like Frank said, all the engineering is taken care of. So there goes several weeks worth of planning. There goes several weeks worth of money and engineering. You got everything you need right there.
So we're going to walk through in a moment here a 3D animation that you're going to show us. You're also going to show us some of the installation of the track so people can kind of put the whole piece together here. So Please go on.
Here's just your other considerations that you could use. And we were just talking about that. This is actually on the other side of the tabletop. This is the inside. You can barely see daylight there, so you see how much room we had to work with on the side pulling that condenser in.
And how much clearance did you have?
You have 2 inches on the side, and you have 4 to 1 inch on the top. So it's really tight space with no headroom.
All right, so if you want to jump over here, Sonny, we'll get you on the 3D animation.
So here's that same view again on the other side of the STG. This is how far we had to come in. This right here is a 6-foot pit, and you know, lifting gear higher. And Hydra-Slide supplied us with all the information we needed to know how much pressure we were putting on this tracks throughout here. This essentially shows you everything. That's your STG tabletop. And then here's the view from the other side. Well, I guess it's just doing whatever it wants to do, Patrick. But yeah, it gives you a better, larger picture of what was going on.
Oh, you can switch to this.
Channel.
You can switch to this one too. Is this the one you're showing first?
Yeah, that just shows a good view of everything.
Okay. Again, so this is in your planning stages, and what's this for? Is this for your who's benefiting
this? This is a 3D lift plan that we drew up. We had to show the client what we were going to do, how we were going to slide it. This is actually drawn to scale, so it shows the dimensions, and we were able to, you know, using the cut sheets provided by us by Hydra-Slide and Lift Gear Hire, we were able to know exactly what to see if this was going to work or not.
Let's switch back to the presentation portion. I need a mouse here. Okay. So what are we doing here?
So right here we're flying tracks into place. Now these tracks are really light. They've got pick points. They've got 4 pick points. So it's really easy to go in. And they just link right together. I mean, it's just like Legos.
And one of the good things about the system, you know, it's minimal manpower putting this together instead of having a crew of 20 people trying to fabricate something. And it, like something you just said, it's put it together like Legos. Put it in place, use a crowbar, and get it pinned up, and you're moving along.
Actually, this next video actually shows how light they are. That's actually just rain on the ground. It had just rained. They're just scooting it around with just a crowbar and putting it in place.
And see right there is some of their, as Don explained earlier, there's some of their connecting bars, and then they just get pinned together, right?
And you can see in that picture right there is the pre-designed lift points already on the system, so you're not trying to bull rig something in as well. They've already done all that for you.
Right. Okay.
So right here you see a picture of the condenser unit underneath the engineered jacking section for it.
So after you've already you've used the hydraulic cylinder, jacked up, and then now at this point it's now on the skid track, and I think we saw this cylinder here advancing, actually doing the pushing, right?
Yeah.
Okay.
And one of the best things about this system is you're not constantly resetting a jacking system. The hydraulic cylinders in it actually come out and they reset themselves on the next set of lugs. So you're not sitting there moving them every single time.
Which is something that saved us a bit, because normally you got people positioned at each cylinder having to reset them as you're going in. And their system, you don't have to do that.
Yeah.
That's also where you can run into a lot of problems, you know, as far as shifting something to the side. These things, they work simultaneously, and they both hit the same set of tracks at the same time as they reset themselves. So
Right.
You know, we had probably 4 guys run this whole thing, this whole show, putting it together and moving it in. We saved a lot of time, labor, engineering hours. We saved, you know, home office hours. We got this done really quick. It was extremely safe. I actually had an elevation change. We went from 6 inches, we made a 6-inch jump up in the air onto another slab. And, you know, everything went fast and fine. We really did not run into any issues with this. If you're worried about using it, you know, Hydra-Slide and Lifted Gear Higher, I actually sent a guy down to show how to use the hydraulic system. He ran our guys through it real quick, and we slid these into place, no problem.
How important was that to you? Was it necessary, or?
You know, I think it's an easy system, but
Yeah.
It's good to show people how it works.
Yeah.
You know.
Yeah, and both companies, I think that's the case. Is it's very safe, and that's first and foremost, especially when you're moving in 300-ton plus units, right? This all sounds great, and you know, it almost seems like you know, a love fest, a sales presentation go on. What, you know, that Billy Banks fellow that used to sell OxyClean on TV, right? That guy. Really, what challenges did you have? What didn't go as expected using this system?
There's absolutely nothing I can say that went wrong. I wish I could complain about something. Like me and Frank have said, normally when we build one of these things, we just build it and we just kind of hodgepodge it, and we just build a piece
Shooting
here,
from the hip.
yeah, a piece there.
As it goes.
And if we've got to get some engineers involved, we do. And, you know, these guys have got all the engineers taken care of, all the parts and pieces are taken care of. It snaps together like a Lego set. It's easy, and there's just so many different applications you can use this for. I would highly consider it before, you know, think about using a crane. If you can't get in touch with, if you really can't figure it out, you should just call Lifting Gear Higher anyways.
Yeah.
Or call Hydra-Slide if you want to purchase one. And just, you know, Lifting Gear Higher can get you one. And if you can't figure it out, they can come down there and show you how to use it. And if you can't do it, Frank and I can come down there and do it.
Nice. There we go. And to that point, I think everybody on this panel here has a LinkedIn profile to learn more about or connect to these guys directly, because again, we know everybody's time is valuable. Some folks might have jumped off. We want you to have an opportunity to meet these guys, and you know, they're real. We went out to dinner last night and had an excellent time. Got a chance to learn about each other. Why are you covering up your face? So I mean, these are real guys, and you know, it's always a testament to have them come in here, and a little bit again from the standpoint of support from Hydra-Slide as well. They've been phenomenal about the training and the support for us. You know, Lifting Gear Higher, the reps, we really appreciate that from a standpoint of tenure. No, we're unmatched there when it comes to rigging. We have well over 800 years of rigging and material handling solution experience on staff, and that's something that other companies can't even hold a candle to. So again, we value you guys, of course, as a customer. Expect to do more with you, as long as I don't make fun of you too much, Sonny. I think you'll come back, right?
Right.
Is there anything else that you want to talk about here? This is the last case study with another customer. To what Don's point was earlier, where an application might be is a low headroom area where you can see in here in the background, you've got an overhead bridge crane, but the capacity wasn't sufficient enough to carry this 350-ton gripper head. This happened not too long ago, so we'll play this one. You'll get the gist of really putting all the pieces together of how simple and easy this is to use, and quick and effective. Very good. So from a standpoint of support, as Sonny and Frank had said, there's on our website, on our YouTube page, there is a video that we did collaboratively with Janine for the skidding system itself, going over a lot of important critical things to consider, as well as Robert Smith, Robert Young, their operations manager. We worked on the Hydra-Pack pump to show how easy it was. So I know we both have sources here At this point, I'd like to open it up to see if there's any questions either via the live Twitter feed, Facebook, or ITI. Jonah, I'm going to flip it back to you here, buddy.
All righty, thanks, Pat. I'm grabbing the screen here. We did have a couple questions come in over the course of the presentation, and I just want to take a little bit of time to say thank you again to Dawn and Janine and Sunny and everybody, and yourself, Pat, for kind of being our host. But no, it's really powerful stuff. It's great to get the background information that was provided earlier, and then seeing it in the real-world application of how we can find a load handling solution. That's what we're all about as a company at ITI when it comes to training solutions. But yeah, just finding the right solution for the situation. Really, really great stuff. So a couple of the questions were about the coefficient of friction on the Hydra-Slide machine. And I believe Dawn covered most of those just later in the presentation. So that's one thing we can check off. This is kind of to everyone. Dawn can take it, or you yourself, Pat. But there were questions asking about equipment for load turning and how that fits in with the skidding system, or really, like, we can skid the load and then we'll have to turn it eventually too. So what kind of recommendations can you guys make about that?
Excellent question. Yeah, that's something I'm going to pass over here to Don to further explain. That's a very unique tool that Lifting Gear has been looking at for several years now. I think it might take a few more steak dinners from Hydra-Slide to persuade us, but that being said, it's a very unique and critical tool in there. So with that said, I'll let Don explain the capacities and the purpose behind those turntables.
Okay. Yeah, over the last couple of years, we've had several requests for something that will rotate loads, and we currently have several different designs, the smallest one being 150-ton capacity with a 6-inch diameter turntable. It's only 4 inches high. So again, it fits in with the slide system, very low profile. From there, we go up to 250 to 500-ton capacity, 8-foot and 10-foot diameter turntables that are about 6 inches high. And we're now just in the final development stages of a 1,000-ton capacity turntable. We've gone metric, and this actually it's almost 12-foot diameter, but it breaks down. It will fit into a shipping container.
That's huge.
So yeah, we've got several different designs of turntables now, and yes, we're going to work on patenting. Yes, that's something that's stable.
Sorry, just to add to that, a lot of these designs have been customer driven. Don designed the first turntable years and years ago, and he kind of said, you know, when I came on, well, it's a really simple thing. It's a steel plate, you know, some grease graphite, turn on it, push the hydraulic cylinders. I don't think anybody's really gonna want those because it's really simple. And in the last 5 years, we've sold them all over the world, and we had requests for, do you have a smaller capacity one? Well, could you build one that goes into a container? Can you build a bigger one? And we're like, yeah, we can build whatever the market needs. So yeah, we do have them, and on the Hydra-Slide website, there are a few videos and photos of exactly how they operate. They operate with the same power units and the same principles that apply to our slide system.
I wanted to add there, both on what they were saying, is I've also seen applications whereby they had another Hydra-Slide heavy track system that was cribbed up above this. When they want to turn 90 degrees, they could crib up on that unit, slide another system yet, and then change direction as well. And then as far as, Jonah, that coefficient of friction question, that we get that a lot through our Facebook. It's covered in our video, but also it's not recommended to use any type of lubricant, whether it's soap, you know, other oils, because again, they've designed it, as Don had mentioned, to actually control this. So that coefficient of friction is specifically designed that way. So I'll turn back over to you, Jonah.
Yeah, no, that's good stuff. Thanks, everybody. Just a couple other questions. Again, stuff that was touched on in the presentation, so I can try to address those to you individually off air because they were touched on. But I just want to thank everybody again for coming on, all of our guests, and then all of the attendees as well, taking time out of your day. to learn something new and hopefully spread the word. And yeah, hopefully it's something that can help you in your day-to-day operations at your work site. So thank you guys. Pat, if you have anything to say with the sign-off, I think we can wrap it up.
Yeah, no, not much. I just, again, thank our guests. Thank you guys for hosting. I mean, we got a good partnership with, again, ITI and some other folks out there, including Hydra-Slide, Robins, and the other manufacturers we work with. So thank you, everybody on the line, for taking the time, and hopefully it benefits you. If you know anybody who will benefit, of course, like and share it on Facebook as well as Twitter, etc. So with that, I'm going to take a breath and some water. Thanks, Jonah.
Yep. Thanks, everybody. Look out for the next Showcase Webinar Series edition coming up in July, and we'll talk to you later. Thank you.